Good morning, you guys. All right, so this is our semester 2 final review number 1. All right, so our first question on the Chromebook, it says, consider the figure given below. If the square is rotated about line L, the solid object formed is a, well, you should draw a picture. So you have a square attached to a line L, and this is a square. That means all the sides are the same, all the angles are 90-degree angles, and all the sides are a 3. It's being rotated around line L. So when we rotate that around, it goes in a circular motion. That means it's going to reach out the same length on the other side, going in a circular motion. So it's going to make this 3-dimensional solid. It's going to make a cylinder. And what do we know about this cylinder? Well, we know that the radius is a 3 because the sides of the square are 3. Which means that the diameter, which would be all the way across the center of the circular base, all the way across from edge to edge, would be 3 plus 3, which is 6. Because remember, the diameter is always double the radius. Radius is always half the diameter. And the height, how tall this cylinder is, well, the sides of the square were all 3s, so that's how tall the cylinder is as well. Okay, so on your Chromebook, you have to select from the drop down that it's a cylinder, and you're going to be selecting that the radius is 3, the diameter is 6, and the height is 3. So you're going to be selecting A, because that shows that the radius is 3. And B says the radius is 6, but no, it can't be both. C says the diameter is 3. Nope, the diameter is 6. D says the cylinder has a height of 3. That is true. And E says the height is 6. That is not true. So A and D were the only correct options to select from those multiple choice options. So to select cylinder from the drop down and A and D from the multiple choice. And that's number 1. Number 2 is, let me get to the next one. This is a drag and drop where you have to see what the 3-dimensional object is after you spin it. So the first one, I'm just gonna bring the Chromebook over here so you guys can see it, because on this one, you're just gonna write down what they were. Okay, so the first one, we've got a triangle on a pole, and when you spin it around, it's gonna make a cone. Not the double cone, just a regular cone. And I just need to drag and drop it. There it goes. This one, well, we know what rotating a square is gonna look like. That's gonna be a cylinder, so I need a cylinder. There it is. So we have a cone, we have a cylinder. This, we got this double triangle thing. When we spin that around, we're gonna get a double cone. And then this one, when we spin it around, we're gonna get a sphere, a ball. So the only real work to show is just to write our answer. So we picked a, what was the first one? A cone. And then we picked a cylinder. And then we picked a double cone. And then a sphere. This is important to write these down because on your test, I'm gonna be requiring the same thing. Because it's hard for me to find your work when it's all over the place being used as scratch paper. I need to see your work, so I need each problem numbered, even if it's so simple as that, okay? Number 3, the log one. A lot of you guys were asking me about this one today. So it's log base 2 of x minus 3 minus 5, and we need to identify all the following points that would fall on its graph. So in Edulastic, it gave us A, B, C, D, E, and F, and they're all coordinates. And what we need to do is take the x values of each of these coordinates and test them out. The first x value is a -1. So we got to plug in a -1 for x. Well, -1 minus 3 is -4. So I'll have log base 2 of -4 minus 5. But that's a problem because we are not allowed to take the log of a negative number. That's a no-no. So automatically this one is going to end up in error. So that one's not on the graph then. The next one has an x value of 3.5, and I need to see if the y value ends up being -6. So we're going to plug in 3.5 for x. Well, 3.5 minus 3 is just a half. Okay, and when we do this, you have to do it by hand because you can't use a calculator on these ones because these are not base 10, that's base 2. So we need to get a double base. Well, 1/2 is the same as 2 to what exponent? Well, remember, fractions come from negative exponents, so it has a -1 exponent. So I can rewrite this as log base 2 of 2 to the -1 power minus 5. You want that double base to cancel out. That means the exponent can come down, and it's just -1 minus 5, which is -6. And that is what it matches with on letter B, 3.5, -6, so B is an option, okay? Next one we need to try is a +1 for x. Well, but when we plug in a 1 minus 3, 1 minus 3 is -2, so we can't plug in negatives into a log, so it's gonna give us error, so that one's not on it. The next one is a 2. Same thing, 2 minus 3 is -1. We can't take the log of a negative. That one's gonna give us an error. The next one is a 5. So let's plug in the 5. 5 minus 3 is a 2. So it'd be log base 2 of 2 minus 5. I need an exponent on the input 2. When there's no exponent on a number, you assume it to be a 1. We need that because we need the double base to cancel, so that the 1 can come down, and then I need to subtract 5 from it. 1 minus 5 is -4. The coordinate said 5, -4, so yeah, that one works. So E is also an answer. And then the last one you need to try is a 4. Plug in a 4 for x. 4 minus 3 is a 1, so it's log base 2 of 1 minus 5. Remember, it's all about the base. I need this 1 to be a base 2. Well, 1 is the same as 2 to what power? What power automatically makes a number turn into a 1? Well, that exponent is a 0. Anything to the 0 power equals 1. So that means 2 to the 0 power is equal to 1. So log base 2 of 2 to the 0 minus 5. We got the double base to cancel, so the 0 gets to come down, and 0 minus 5 is -5. And F was the coordinate for -5, so that one works. So F was an answer. So B, E, and F for number 3. On to number 4. So for number 4, this is a unit circle question. So it's gonna help if you have your unit circle drawn out, and I was telling you guys to do that. I was telling people to just draw what you need, but you're gonna end up needing almost the whole thing. So for number 4, I'm just gonna go ahead and draw a whole unit circle. Okay, dividing it into 3, because you need to know it. On the day of the final, I will give you a partial unit circle with only the first quadrant, but you gotta know all of them. So we've got 30, 45, these are the degrees, 60, 90, 120, 135, I'm just gonna blaze through it, 150, 180, 210, 225, 240, 270, 300, 315, 330, a full circle, 360. I forgot my 0. Okay, and then the radians. Well, 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, 2 pi. Okay, and then we need our coordinates. So we've got 1, 0. Square root of 3 over 2, 1/2. Square root of 2 over 2, square root of 2 over 2. 1/2, square root of 3 over 2, 0, 1. 2 pi over 3 and pi over 3 are the same, except x is negative in this quadrant, so negative 1/2, square root of 3 over 2. Negative square root of 2 over 2, square root of 2 over 2. Negative square root of 3 over 2, 1/2. Negative 1, 0. Everything's negative in the third quadrant. Negative root 3 over 2, negative 1/2. Negative square root of 2 over 2, negative square root of 2 over 2. Negative 1/2, negative square root of 3 over 2. 0, negative 1. Now x is positive, y is negative down here, so 1/2, negative root 3 over 2. Square root of 2 over 2, negative root 2 over 2. And square root of 3 over 2, negative 1/2. And that is the unit circle. Whew, okay. All right, so I'm gonna bring up my computer and let me move this out of the way. Okay, because it was drag and drop. And yeah, here we go. So first one is sine of 5 pi over 3. So on my unit circle, 5 pi over 3 is right here. And maybe we should add to our unit circle diagram here that in an ordered pair, cosine is x, sine is y. Some of you guys have been switching that. Cosine is x, sine is y. So the sine, the y value at 5 pi over 3 is a negative square root of 3 over 2. So I'm going to drag and drop, negative square root of 3 over 2. There it is. Cosine of 2 pi over 3. So the x value at 2 pi over 3 is negative 1/2. So I got to find that and drag and drop it. Sine, the y value at 3 pi over 4 is square root of 2 over 2. Cosine, the x value at 7 pi over 6 is negative square root of 3 over 2. The sine of 5 pi over 6, the y value there is 1/2. The sine, the y value at 5 pi over 4 is a negative square root of 2 over 2. The cosine of 7 pi over 4, the x value is positive square root of 2 over 2. Sine of 2 pi over 3, the y value at 2 pi over 3 is positive square root of 3 over 2. Sine, the y value of 3 pi over 2 is negative 1. Cosine, the x value at pi over 2 is 0. Where's my 0? There it is. Sine of 7 pi over 4, the y value at 7 pi over 4 is negative square root of 2 over 2. Cosine of 5 pi over 3, the x value at 5 pi over 3 is a positive 1/2. Where's my positive 1/2? There it is. The cosine of 11 pi over 6, the x value there is square root of 3 over 2, positive. Cosine of pi over 4, that's regular pi over 4, cosine is the x value square root of 2 over 2. And then sine of 7 pi over 6, so the y value at 7 pi over 6 is negative 1/2. And that one was the last one. Okay, so really all the work you need to show for number 4 is your unit circle because we pretty much used all of those. Okay, so that was number 4. Okay, number 5. So number 5 says find the equation in vertex form for the parabola with focus 1, 4. So we've got a focus at 1, 4 and a directrix of x equals 5. So we need to draw a picture. We need to draw a graph. Okay, let me refocus this. Okay, so 1, 2, 3, 4. This is my focus. A focus is not the same as the vertex, by the way. X equals 5 means I got to go through the x at 5. 4, 5, 2, 3, 4, 5. So my directrix is the vertical line that goes through there, which means because it's going through x that this is a sideways parabola. The vertex should be smack dab in the middle. 1, 2, 3, 4. Half of 4 is 2, so my vertex is right there. which means that I'll put it over here, my vertex is 3, 4. Kind of wrote it a little bit lower, but that's okay. And because the directrix is always behind the vertex, this parabola is opening to the left, to the left, to the left. So this distance tells us the p-value. It's 2 units, but because it's facing the negative direction, it's negative, okay? And our vertex, oops, I didn't finish it, is our hk. This is a sideways parabola, so we're using the sideways formula. X equals 1 over 4p times y minus k quantity squared plus h. So we got to plug in all the things. So x equals, because the p-value is a negative, we always throw that negative in front. Okay, 4 times 2 is an 8. Y minus the k, well the k is a 4, so y minus 4 quantity squared. The h is a 3, so plus 3, and then this is what you needed to type into the box. I've noticed a lot of students were forgetting the negative, and a lot of students were forgetting that power of 2, and a lot of students were putting y equals instead of x equals. And that's number 5. Number 6 is find the equation of a parabola. So it's another parabola question with a focus of 0, 1 and a directrix at y equals -1. Okay, so we got to draw another picture. So the focus is at 0, 1, so my focus is right here this time. Remember, that's a focus, not a vertex. The directrix is at y equals -1, so it's got to go through the y at -1, which means it's a horizontal line, which means the vertex should be smack dab in the middle, which happens to be the origin. So because the directrix is always behind the vertex, this parabola is facing up. So what do we have here? We've got an upward facing parabola. Remember, this distance or this distance is our p-value. It's facing up, so it's a +1 because that distance is only 1 unit. Okay, and our vertex is 0, 0, so our h and our k are both 0. We're using the upward facing parabola formula, so y equals 1 over 4p x minus h quantity squared plus k. Okay, and we're going to plug in the h, the k, and the p-value. The p-value is a +1, so y equals 4 times 1 is a 4, so 1/4. X minus 0 is just x, so x squared, and then plus 0, you don't need to put a +0 when it's a 0, so that's it. And that's what you would type into the box. And actually in the Edulastic box, it already has the y equals part. You just need to type in 1/4 x squared and you're good to go. Number 7. Number 7 says, consider the pair of functions given in the first column. Determine if the two functions are equivalent after expressing the functions in logarithmic form and comparing them. So it's either going to be yes, they're equivalent, or no, they're not. So let's look at the first pair. The first pair is y equals 2 to the x and x equals log base 2 of y. The best way to tell if these are equivalent is to look at the log one. Remember, it's all about the base. But we like having the base on the left. So I'm gonna flip it like a pancake. It's all about the base, right? So we're gonna do our roundabout. You start with the base and you work your way around to convert it into exponential form. So 2 to the x is equal to y. That's the same thing as this. So this pair was a yes, they are equivalent. So let's look at pair number 2. Well, pair number 2 is y equals 1/2 to the x power versus x equals log base 2 of y. Well, we already said x equals log base 2 of y is paired with y equals 2 to the x. A base of 2 and a base of 1/2 are not the same. So this is a big fat no. These are not a pair. So you would type in no into that box. Pair number 3. We've got y equals 4 to the x and x equals log base 4 of y. Same thing. I'll keep the base on the right this time, but remember, if it's on the right-hand side, you have to do your roundabout clockwise instead of counterclockwise. So that would go 4 to the x is equal to y, and that's exactly what we've got here. So this one was a yes, they are equivalent. And then if you look at pair 4, it already says no. So, and you can't type in anything because it already typed in no for you, so you don't even need to look at it. But they're not equivalent anyway, and that's number 7. Number 8 says to solve the equation. So we've got log base 5 of x plus 4 plus log base 5 of x is equal to 1. And we got to solve that. Okay. Well, first things first, whenever we're adding logs, we have to remember what this means. Adding logs means to multiply the inputs together. So this will be log base 5 of x times x plus 4. So the distributive property is coming up soon, okay? I want to get these x's out of that log. In order to do that, I need to inverse it. So the inverse opposite of a log base 5 is an exponential base 5. But whatever I do to one side of the equation, I got to do to the other. We got the double base, so I could bring this down, and as I bring it down, I'll go ahead and distribute the x. X times x is x squared, x times 4 is 4x, 5 to the first power is 5. Anytime you get a quadratic, you need to get everything over on one side and 0 on the other, because you're going to use product sum to finish it off. So we need to subtract that 5. We'll get x squared plus 4x equals, wrote it weird. We'll get x squared plus 4x minus 5 equals 0, okay? And then we'll product sum it out. So I'll put the product sum over here, and I'll rewrite this up here because I want to utilize this space. All right, the product is a times c. 1 times -5 is -5. The sum is a 4, so two numbers that multiply to a -5, well, it's got to be 1 and 5. But one of these numbers has to be negative, and since it's adding up to a 4, that means the smaller number should be negative, because -1 plus 5 equals 4. These are the droids I'm looking for. So I'm going to have x minus 1, x plus 5, and then we break them apart and set them each equal to 0 and solve. So I have x equals 1 and x equals -5. Then I got to check for extraneous solutions. Remember, what kind of numbers are we not allowed to plug in to a log? We're not allowed to plug in negative numbers. I can't take the log of a negative number. It's going to be error. So this one is my extraneous. This one is my actual solution. Okay? So on Edulastic, for x equals, you have to type in the actual solution. So you just have to type in a 1. And then it says find the extraneous solution of the above equation, if any. And from the drop down, you had to select x equals -5. And that was number 8. Number 9, we've got some right triangle trig here. So we need to draw the picture. Got a right triangle. And we've got a vertical side of 3. We've got this angle is x degrees and the hypotenuse is 25. So we need to figure out which trig ratio would you use to solve for the missing angle. So we're trying to find this missing angle because that's where the x is. To the angle, the 3 side is adjacent to it. The 25 side is the hypotenuse. Adjacent over hypotenuse, we're using SOHCAHTOA. That's the ka of SOHCAHTOA. So that means we'd be using the cosine of angle x is equal to adjacent over hypotenuse, so 3 over 25. And then when we solve this, to get x out of the cosine, we need to take a cosine inverse. You only use inverses for angles of the ratio 3 over 25. So answer A is the first part to pick for part A. So this part was the answer, letter A, okay? Then you have to actually solve it. For part B, you have to find the missing angle. So if you're using this calculator, you just hit second cosine and 3 over 25 and hit equals. If you're using the black calculator, you have to get 3 divided by 25 equals first, and then second cosine. should be to the nearest degree 83 degrees. So x is approximately 83 degrees. And this was the part B part that you needed to type in. That was number 9. Number 10. This one is a drag and drop. This is the Freaky Friday ones. You had to find the inverses. So we've got 3 functions. I'm just gonna write them all down. F of x equals 6x plus 8. F of x equals 2x minus 10. F of x equals x plus 5 over 4. Okay, so we did this in the warm-up today. So first of all, we need to change f of x to a y. That's step 1. Step 2, Freaky Friday. So x equals 6y plus 8, and we need to solve for the y. So I'm gonna need to subtract 8 from both sides. So when I do that, I'll have x minus 8 on the left and just 6y on the right. Then I need to divide everything by 6. I like to do it individually, but in this particular one, they left it like this altogether. So y equals x minus 8 over 6. So that's the one I need to drag and drop to that spot. And then for this one, same sort of thing. I've got to change f of x to a y. Freaky Friday. So I got to switch the x and the y's places and solve for y. So this time I'm gonna need to add the 10 to both sides, so I'll have x plus 10 on the left and just 2y on the right. And then I need to get rid of the 2, so I'm gonna need to divide everything by 2. So then I'm gonna get y equals x plus 10 all over 2. And I'll drag and drop that option into the second one. So obviously the third one must be whatever's left, but we're still gonna do it. Y equals x plus 5 over 4. And then we got a Freaky Friday, so we'll get x equals y plus 5 over 4, and we still need to solve for y. So first of all, we need to get 4 out of the denominator. Fraction bars mean division. The opposite of division is multiplication. So I need to multiply both sides by 4. And then I'll get 4x equals y plus 5. And then I need to get rid of that plus 5, so I need to subtract 5 from both sides. So I'll have 4x minus 5 on the left equals y on the right. And I'll drag and drop that to that spot, okay? So these were your drag and drop answers for these respective functions. And that was number 10. Number 11. Solve algebraically for all values of x. So we've got the square root of x plus 2 plus x equals 0. Okay. So what I gotta do is I need to isolate that radical first. I need to get this by itself. So I gotta move that x. It's being added. The opposite of addition is subtraction. So I need to subtract x. So I'm gonna get the square root of x plus 2 equals negative x. Then I need to undo the radical. The opposite of a square root is squaring. So I need to square both sides, including that negative in front of the x. When you square a square root, the stuff inside comes out. Negative x times negative x is a positive x squared, because a negative times negative is positive. Anytime we get an x squared, we need to get everything over on the same side as it. So I need to subtract the x, subtract the 2 from both sides, because I want 0 on that left-hand side this time. So x squared minus x minus 2, and we're going to product sum this out. So I'm going to put this up here. We'll do the product sum. Okay? The product this time, a times c, 1 times negative 2 is negative 2. The sum, the b value is a negative 1. So to get a 2, it's got to be 2 and 1. And to get a negative 2 that adds up to a negative 1, that means the 2 should be negative, because negative 2 plus 1 adds up to negative 1. So these are the droids I'm looking for. So this factors down to, oops, that's an equals, to x minus 2 and x plus 1. Break these apart, set them each equal to 0. So x is going to equal positive 2 and x is going to equal a negative 1. And then you gotta check them. When you check them, you plug them back into the original, okay? So when I plug that back in, I'm gonna check the 2. Square root of 2 plus 2 plus 2. Is that gonna equal 0? No, it's not. 2 plus 2 is 4. The square root of 4 is a 2. 2 plus 2 is 4. 4 does not equal 0. That one doesn't work. So this one didn't work. It's extraneous. Now let's try the -1. -1 plus 2 plus a -1. Does that equal 0? That one works because -1 plus 2 is 1. The square root of 1 is 1. 1 plus -1 does equal 0, so that one works. So the only solution is x equals -1, and you would type that into the box. Number 12. Number 12, on this one, we don't really need to write much down. I'll show you what I do want you to write down though. So for number 12, it says a function is graphed on the coordinate plane. Select the function that is graphed on the coordinate plane. Well, all parent functions start at 0, 0. So this one was shifted to the left 5 and up 2. So I need to see a +5 and a +2, because remember, plus with the x means left. Plus on the outside after the x means up. So left 5 up 2, B is it, okay? So for number 12, you just had to put that it's y equals square root of x plus 5 plus 2, because this one means left 5 and up 2. And this was letter B. Oops, you guys can't see what I wrote. My bad. Okay, that's number 12. Number 13. Which of the following cube root functions is not one-to-one? So when you're looking for something that is not one-to-one, you're looking for extra junk in the trunk. Which one has extra junk? Well, I'm gonna bring this back up again. The one that has extra junk is the one that's got stuff that we don't normally like to see underneath a radical. Like the 2x plus 7, that's okay. We'll be able to figure out the shift to the left or to the right. In this case, because of the plus, we know it's going left. And because there's a number out front, there's a vertical stretch or shrink in front. This one shows me to the right one, and the divide by 3 means we've got a vertical shrink. This one's got an x squared. That would be considered extra junk in the trunk. Okay, the trunk being the radical. And then the last one's not, because I could see, oh, it's going left 11 and down 3. As long as I can see what the shiftings are, it's one-to-one. When it's got extra junk in the trunk, it's not one-to-one. So the one that was extra junk in the trunk was letter C. And so that one was y equals, or f of x equals, it doesn't matter, the cubed root of 2x squared plus 4. So that x squared is the extra junk. Okay. Number 14. Okay, so I've got 6 over x squared minus 25 plus x over x plus 5. We are adding fractions. So in order to add fractions, we need to get a common what? That's right, if you said denominator, we need to get a common denominator, which means we need to see what's going on in these denominators. And this one, I need to factor. So I'm gonna have 6 over x squared minus 25 is a difference of 2 perfect squares. It's gonna have the same factors, one with a plus, one with a minus. So we've got an x plus 5 and an x minus 5. Okay, the other fraction has an x plus 5. What it doesn't have is it doesn't have an x minus 5, and I need these to be the same. So to make this one have an x minus 5, I have to multiply by x minus 5, but whatever I do to the bottom, I gotta do to the top. Okay, and we're gonna need to distribute this. So now that we have a common denominator, you keep the denominator, x plus 5, x minus 5, and now we are allowed to add the numerators. So I have 6 plus x times x is x squared, x times -5 is a -5x. And that is not in standard form, so I want to rewrite that in standard form. So that would go x squared minus 5x plus 6 over x plus 5, x minus 5. And the only other thing you want to check is to see if anything else could possibly cancel. So let's factor the numerator and see. So product summit, the a times c is 1 times 6 is 6. The sum is -5. And so I need two numbers that multiply to 6 and add up to -5. So let's see, it can't be 6 and 1 because I need to subtract to get that -5. And this is a +6. So I need two negatives because two negatives multiplied together make a positive. So -2 times -3 would work. That multiplies to +6. And -2 minus 3 adds up to a -5. So these are the droids I'm looking for. So that would be x minus 2 and x minus 3, but that's not going to cancel with anything down there. So I'm just going to leave my answer like this. You could type that into the box. And that was number 14. Okay, for number 15, it says we're given this function, so I'm writing it down. Y equals x squared minus 36 over x squared minus 5x minus 6. Okay, and we need to, what does it say? Determine the equation for its horizontal asymptote. Put your answer in exact decimal format. So part A is to find the HA. Okay, so this is where we have to ask ourselves, big top, big bottom, or same? And I'm talking about the degrees. And I see that the highest degree in the top is a power of 2, the highest degree in the bottom is a power of 2, so they've got the same degrees. When it's the same degrees, you take the ratio of the leading coefficients. So it would be y equals the LC of the top over the LC of the bottom. The leading coefficient in the top over the leading coefficient in the bottom. The leading coefficient in the top is a 1, the leading coefficient in the bottom is a 1, so that means the HA is y equals 1 divided by 1, which is 1. So there's my HA. Okay, for part B, it asks for determine the coordinates of the point of discontinuity that is a whole. Write your answer in coordinate format. If necessary, leave your answer in simplified fraction form. So I need the whole. And it said in coordinate format, so I need an ordered pair. I need an x value and a y value. So to find all that, I need to factor the numerator and the denominator. The numerator is easy. It's a difference of two perfect squares. So those factor down to two binomial factors, one with a plus, one with a minus with the same stuff inside. And we can split the x into x times x is x squared and 6 times 6 is 36. X plus 6, x minus 6. In the denominator, that one also is going to factor down to two binomial factors, and I need to do product sum to find what goes inside them. The product is 1 times -6, which is -6. The sum is -5. So I believe I'm using 6 and 1, and the 6 should be negative because -6 plus 1 adds up to -5. These are the droids I'm looking for. So I need x and a -6 and x and a +1. Okay, so now I could tell what my common factor is. I have a common factor of x minus 6 in the top and the bottom, so that means I have a whole at x minus 6 equals 0. You have to set it equal to 0 and solve. Some of you guys forget to do that. You have to add the 6 over, so x equals +6 is the x coordinate of the whole. So I need to see what's left. I've got an x plus 6 in the top left over and an x plus 1 in the bottom left over. So I need to use what's left over to find my y value. So what I need to do is I need to substitute in this x value of 6 into these x's. So 6 plus 6 over 6 plus 1. 6 plus 6 is 12. 6 plus 1 is 7. And it said to leave it in simplified fraction form. So you can leave it just like that, and that is the whole. And that was number 15. Number 16. Can you lock the door? Okay. Number number 16. So on this one we have a graph, and I'll show you guys that graph. But I am going to write down, this is the parent function that is being moved around on the graph, y equals 3 over x. Okay, so in this graph, remember, all parent functions start at the origin. So we have to look at where the asymptotes moved. We moved left 2 and down 1. Okay? So we know that this went in the graph left 2 and down 1. So it went left 2 and down 1. Nothing got switched around because the parent function of the regular, like y equals 1 over x, they have asymptotes on the y and the x axis, and the curves hug the walls just like this. Our graph looked like that, right? So because we're in the bottom left-hand corner and the upper right-hand corner, there's no reflection, so there's no negative in front of our equation. So I know that it's a positive 3 over something, but because it went left 2, remember left means plus, so you need plus 2 with the x in the denominator there. Down 1 means negative, so minus 1. So this should be the one I'm looking for, and that is option B. 3 over x, no, that's not B. It's D, y equals 3 over x plus 2 minus 1. So D was the correct option there. And that's number 16. Number 17 says what value of x makes the equation true? So we've got 1 over x minus 3 equals x over 9 minus 3x, okay? And because we have a fraction equal to a fraction, to figure out what makes this true, we basically have to solve it, and we can cross multiply, excuse me, just like we did with law of sines, except we're not dealing with sines here. So 1 times 9 minus 3x, you have to make sure to put parentheses around it, but when you multiply by 1, nothing changes, equals, and then across the other direction, x minus 3 times x. Now that one, I need parentheses around for sure because I'm going to have to distribute here next. Okay, so x times x is x squared, x times negative 3 is a negative 3x, and then 9 minus 3x on the left-hand side of that equals. Okay, we've got a quadratic, so we need to get everything over on one side and 0 on the other. I'm going to stick with the side that has the x squared. So I'm going to add that 3x. Hey, what's going to happen to the 3x's on both sides? They cancel. And let's subtract the 9. So we get 0 equals x squared minus 9. That is a difference of 2 perfect squares. So those factor down to 2 binomial factors, one with a plus, one with a minus. Split the x, split the 9. X plus 3x minus 3. So when we get our two solutions, x equals negative 3 and x equals positive 3 when you solve each of those, okay? Now, because we were solving a rational equation, we have x's in the denominator, we have to figure out which one can we not use. If I were to plug in a negative 3 right here, negative 3 minus 3 is negative 6. I can have a negative number in the denominator of a fraction, that's totally fine. But if I plug in a positive 3, I'm going to get 3 minus 3. I can't have 0 in the denominator. So this one doesn't work because it makes a 0 in the denominator, so it's extraneous. So the only solution is x equals negative 3. So from the drop-down menu on Edulastic, you would pick negative 3. And that's 17. I have this empty space right here, so I'm going to put number 18 up here. Says which is the cubic polynomial in standard form with roots 0, 2, and negative 1. So that means we have a root of x equals 0, we have a root of x equals 2, and we have a root of x equals negative 1. Okay, so we're working backwards to figure out what polynomial these came from. So in factored form, x equals 0 is just a factor of x. In factored form, x equals 2 is a factor of x minus 2. In factored form, x equals negative 1 is a factor of x plus 1. And then we just need to multiply these all out. We can only multiply 2 at a time. So let's multiply these two together first. So x times x is x squared. X times 1 is x. Negative 2 times x is negative 2x. Negative 2 times 1 is a negative 2. Clean it up a little bit, combine like terms. 1x minus 2x is a negative x. Bring down this little x and multiply him in. So when you multiply him in, distribute him in, you're gonna get x cubed minus x squared minus 2x. And that's our final answer. So everything is negative. So it should be C. That's 18. Number 19 is a long division problem, so I need more room for that. So I'm gonna flip this over. It says use long division to find the quotient. And let's see, I'm gonna just set it up. So negative 2x plus 3 is what I'm dividing by. And I'm dividing this into 4x to the 4th plus 12x cubed plus 7x squared plus x plus 6. All right, and here we go. So my first goal is to get a 4x to the 4th. So I need to ask myself, what do I multiply by negative 2x to get a positive 4x to the 4th? Well, I need a negative times a negative, so I'm going to need a negative 2, because that'll give me the 4. And to make that x and x to the 4th, I need to multiply by an x cubed. So notice how I line them up, so they're nice and orderly. And then we distribute. Negative 2x cubed times negative 2x is a positive 4x to the 4th. Negative 2x cubed times 3 is a negative 6x cubed. And then we have to do the sign change. So this becomes negative, this becomes its opposite, so positive. These should cancel. 12x cubed plus 6x cubed is 18x cubed. And then you bring down the next term and you do it all over again. So our next goal is an 18x cubed. So we have to ask ourselves, what do we multiply by negative 2x to get 18x cubed? I'm gonna need a negative, because I need a negative times a negative to make a positive, 9x squared. It should follow in order with what's underneath it. Now distribute. Negative 9x squared times negative 2x is 18x cubed. Negative 9x squared times 3 is a negative 27x squared. And then we do the sign change. This becomes its opposite, this becomes its opposite. These should cancel because they're opposites. 7x squared plus 27x squared is 34x squared. Bring down the next term. And we do this all over again. So now our new goal is a 34x squared. So we need to ask ourselves, what do we multiply by negative 2x to get positive 34x squared? Let's see, half of 30 is 15, half of 4 is 2, 15 and 2 is 17. So I need a negative 17x. Negative 17x times negative 2x is a positive 34x squared. Negative 17x times 3 is negative 17 times 3. 51x. And then we got to do the sign change. So this becomes negative, this becomes positive, those cancel out. X plus 51x is 52x. And then we bring down that last term, and we just need to do this one more time. Our new goal is a 52x, so we need to ask ourselves, what do we multiply by negative 2x to get 52x? Well, half of 52, half of 50 is 25, half of 2 is 1, so 26. So need to multiply by a negative 26. Negative 26 times negative 2x is a positive 52x. Negative 26 times 3 is negative. 26 times 3 is 78. Then we have to do the sign change. So this is negative, this becomes positive, those cancel. 6 plus 78 is what, 84? So there's my remainder. So my remainder has to be, it's positive, so I'm gonna add it on at the end. 84 over the divisor, negative 2x plus 3. So this is the answer that you had to type into the box. Because there is a remainder, that means that negative 2x plus 3 did not divide evenly. If it did, I would get a 0 remainder. So for part B, it says, based on your answer in part A, is negative 2x plus 3 a factor? The answer would be no. It did not divide evenly, so no, it's not a factor. And that was 19. Number 20, it says find the roots of x to the 4th plus 3x cubed minus 5x squared minus 9x plus 10. And we need to find the roots. And there's 4 drop-down menus, which makes sense because it's to the 4th power, so there are 4 roots. So in your first drop-down menu, it gives you clues. You can pick 1, -1, 5, or -5. Let's start with a +1. We're going to try that using synthetic division in the box. So write down the coefficients, 1, 3, -5, -9, and 10. Bring down the first term, it's a 1, and then you multiply times the number in the box. 1 times 1 is 1. Then you add down, 3 plus 1 is a 4, and then you do it again. 4 times 1 is a 4, -5 plus 4 is -1. -1 times 1 is -1. -9 minus 1 is -10. -10 times 1 is -10, and we get the 0 that we want. This is what we want. That means that x equals 1 is a root. You can select that from the first drop-down menu. So now we just divided out an x. So we are going down from an x to the 4th to an x to the 3rd now. But I want to keep going. So I'm going to rewrite these new numbers, 1, 4, -1, and -10. You don't need the 0 at the end. And we're going to do this all over again with the new numbers. In the second drop-down menu, you have 2, -2, 10, or -10. Let's try a +2 and see what happens. So do the same things. Bring down the 1. 1 times 2 is a 2. 4 plus 2 is 6. 6 times 2 is 12. -1 plus 12 is 11. This one's not going to work. I'm not getting a 0. So this one didn't work. Okay, so let's try it again. Let's use the -2. 1, 4, -1, -10. Bring down the 1. 1 times -2 is -2. 4 minus 2 is 2. 2 times -2 is -4. -1 plus -4 is -5. -5 times -2 is +10. We got our 0. So x equals -2 is our second root. You can select that from the drop-down menu, the second drop-down menu. Okay? The last 2 drop-downs are decimals. So here's what you got to do. We divided out an x, brought it down to an x cubed. Divided out another x, so now this represents 1x squared plus 2x minus 5, and we can product sum it. Actually, we can't product sum it because it's not factorable. We have to use the quadratic formula. So we need to identify the ABCs. A is 1, B is 2, C is -5. Then it goes x equals -b plus or minus the square root of b squared, which is 2 squared, minus 4 is 1, c is -5, all over 2a. And then you want to clean that up. So we've got -2 plus or minus 2 squared is 4, minus 4 times 1 times -5, double negative turns to a positive. 4 times 1 is 4, 4 times 5 is 20. So that's a 4 plus 20, which is 24, all over 2. So remember, the plus or minus gives us 2 solutions. So I have to do this twice. So I need to do -2 plus the square root of 24, which is approximately 2.9. oops, I didn't divide by 2, sorry. 2.9 and then divide that by 2, and that's 1.4. And then -2 minus the square root of 24, which is -6.9, and then divide that by 2, and I get -3.4. So these are my 2 other solutions that I need to select from the drop-down menu, +1.4 and -3.4. And that's number 20. Number 21 is a graph. And I'm just gonna draw a quick little sketch of what we've got going on here. It's the funky W. It looks kind of like this. Okay, there's no numbers. Well, there are numbers on this graph, but it doesn't matter. Okay, so because both ends are facing up, I know that this is even. Up or down, both going in the same direction, the end behavior is even. But because we're facing up, I know that this is also a positive, because up is positive, down is negative. And it's not a parabola, but it's like a parabola. So because it's not a parabola, that means that this has to be an x to the 4th, which means that there are 4 roots. I see 2 of them right here, because that's where they cross the x-axis, that's 2 of the roots. So that means that there are 2 real roots. But I know because of this power of 4, there should be a total of 4 roots. That means that the other 2 must be imaginary roots. So there were drop-down menus on this one. So obviously it's got an even degree. Because it's facing up, the leading coefficient is positive. There are 2 real roots and 2 imaginary roots. So these were the answers. Even, positive, 2 real roots, 2 imaginary roots. And that was 21. 22, I won't have room right here, so I'm gonna grab another sheet of paper. 22. It says use the remainder theorem to determine which of the following binomials are factors of p of x equals x cubed minus 2x squared minus 5x plus 6. Okay, and they give us a list of options to try. So let me show you that real quick. So these are my options. So in synthetic division, I want to try a 1, a -1, a 2, a -2, a 3, or a -3. Remember, we always start with a +1 first, so I'm going to check F first then, and then we go from there. Also, FYI, I should only be selecting 3 answers because that means that there are 3 roots, which means that there are 3 factors. Okay? So I'm going to try the 1 first in the corner box, synthetic division. So 1, -2, -5, and 6 are the coefficients. Bring down the 1. 1 times 1 is 1. -2 plus 1 is -1. -1 times 1 is -1. -5 minus 1 is -6. -6 times 1 is -6. We got the 0. It works. So x equals 1 is a root, which means that x minus 1 is a factor. So we found a factor. So there's 1. Now, this was a cubic, so we just divided out an x. So that means this is a 1x squared minus x minus 6. So all we have to do is product sum it to find the last 2 factors. The product is -6, the sum is -1. So let's see. It's going to have to be a 3 times a 2. One of these has to be negative though. I think it's the 3 because -3 plus 2 equals -1. These are the droids I'm looking for. So this factors down to x minus 3 and x plus 2. So those are the other 2 factors. So the options that you needed to select then were x minus 1, so that was F. X minus 3 is B, and x plus 2 was C. So B, C, F if you go in order. And that was number 22. And that was all the questions on this review.